Hello, I've had a question in Unit 4, Lesson 6, and I'm looking at question number 28. And this is from the second part of the homework here. So it says, suppose there's a semicircle below the rectangle as well as above it. So if I draw my rectangle and put a semicircle above and below, I'm going to call the rectangle that side length, this side width, which would mean my constraint equation, or one of my constraint equations, would be the radius of the circle is half the width. So that's one constraint equation at this point. We want to find the dimensions of the window to admit the most sunlight. So what we're trying to optimize here is area of this shape. So area will equal length times width for the rectangle, plus, because those two semicircles will end up making a full circle, so it's pi r squared. Also, it says that we have a perimeter of 8 meters, so that is going to be our another constraint equation, or another part of the constraint equations. So the perimeter for this would be 2L, and remember with perimeter, it's the distance around the outside of the shape, so we don't include the width in this case. So it would be 2L's plus pi d. Alright, pi d is the circumference of a circle. So we know the perimeter is going to be 8, 2L plus, I'm going to get rid of the d for diameter, because that's just going to be W. So now I can simplify. I want to get everything in terms of W, so that means I'm going to solve for L. So that would mean that 8 minus pi W equals 2L, or 4 minus pi by 2 W equals L. So I now have my two constraint equations that I can use in my area formula. So that means area would become, length is 4 minus pi by 2 W times W plus pi, and the radius is 1/2 W squared. So I want to clean this up before I do anything else. 4W minus pi by 2 W squared plus 1/2 squared is a quarter, so I'm going to have pi by 4 W squared. Now I'm going to take the derivative of area with respect to width, as we do with optimization questions, and I end up with 4 pi W plus pi by 2 W. Now with optimization, we let that derivative, we're optimizing area, so we're going to make it equal to 0. So we're finding max min. 0 equals 4. I'm going to factor out a negative W, which would leave me with pi minus pi by 2, which means W. Pi minus pi by 2 is pi by 2 equals 4. Width would equal 8 divided by pi. Alright, so that is what the width will equal for this question for optimization. And I'm just going to gain a little bit of room here. If that is the case, then my radius would equal 1/2 W, which would be 1/2 of 8 over pi, which would be 4 over pi. So the radius is going to be 4 over pi. And if we take it one step further and check what our length is going to be, that would mean that we'd substitute that value in. So we'd have 4 minus pi by 2, 8 over pi equals L. Pi's would cancel, and we'd end up with 4 minus 4 equals L. L equals 0. So what that means is optimal shape here is simply just a circle, which is actually true. For optimizing shapes, circles and spheres are always the best, followed by cubes. So in this case, maximum light would be just having a circular window. If you have any questions, let me know, and I'll try to clarify.